we're going to solve using logs. All right? So, I'm videoing, so this is going waiting, and it's all going to be waiting and waiting. Right. The power of logs is to do things that we can't do in our brain. All right? So, we need our calculator to help us out here. If I give you the question 2 to the power of x equals 7. There is a way your calculator, not using logs, can tell you the answer to this. Does anybody know what it might be? No. You can use your solver. Now, the problem here is, though, if you use your solver and you don't give any evidence, you'll get no credit for it. They don't want to know you can use your calculator very cleverly. They want to know you can use your brains to actually do this mathematics. So we could put this in our solver, in our equation solver, and it will give us the answer. But that's not what we're going to do. We're going to learn to use logs to solve it. So 2 to the power of what equals 7? What about a guess? Next thing we'd like to do is have a guess. So we know that 2 to the power of 2 is, and 2 to the power of 3 is, 2 times 2 times 2 is 8. So it's going to be somewhere between x being 2 and 3. Probably closer to the 3 end. All right? So, going to guess. And the reason we guess is just to make sure that our calculator doesn't tell us a whole lot of porkies. 2.8-ish, give or take. Now we need an actual method to do this. And the way we're going to use it is we're going to rewrite our exponents in log form. So to do that, that first thing, 2 to the x, becomes x log. So we're going to take logs of both of them first. Log of this side equals log of that side. That's been true in all of our solving. We can do the same thing to both sides and it's still equal. And then we're going to do what we just said. Take that x and stick it in the front. X log 2 equals log 7. We just want x. What is x doing here? It's multiplying. So we need to get rid of the log 2 by dividing it. So we would write it like this if we were writing it in long form. All right? Cancel, cancel. X equals log 7 divided by log 2. Now, you'll notice there's no base. There's no number here. That means it's 10, which means we're allowed to use the button on our calculator. So we push log 7 divided by log 2, and hopefully the answer is somewhere close to 2.8. Log 7 divided by, don't use the fraction button. 2.89? 8.1. Oh, we were really close. Okay? So 2 dp?
Yeah.
Is that one rounded? Yeah. Okay, good. So that's the process. It's called taking logs of both sides, funnily enough. And we can use it to solve. So this was the first question in one of the things last year. Here it is. 3 to the power of 4x equals 30. This is for 2 marks in this question. 1 because you gave it a go and 2 because you got it right. Okay. Take logs of both sides. Log 3 to the power of 4x equals log 30. So 4x log 3 equals log 30. So 4x equals log 30 divided by log 3, and x will equal whatever that is divided by 4 equals. So you need a calculator, because you can't do logs in your head. So we get log 30 divided by log 3 equals, helps if you turn your calculator on first. My goodness, not doing well here. Right. 3.096, I'm going to go with 3.096 divided by 4, 0.774. 0.774 to 3 dp. So that, which took us about 20 seconds, is worth 2 marks out of the 24 possible in the paper. That's pretty fair, isn't it? And that's considered to be the hard part of this topic. Right? Or we might have something like this one. This would be merit, maybe even excellence. It's got 2 things with powers. Boom, 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 boom. Let's use logs. All right? I'm going to jump over this step to this step now. Take the power, write it down. 3x log 6 equals 2x minus 3 log 4. Now going to uncross multiply. So I'm going to get rid of that to this side and that to this side. So 3x over 2x minus 3 equals log 4 stays, log 6 goes underneath. This is a number. What that number is, our calculator will tell us. We don't know. Never bothered to try and learn logs. 0.7737. What happens to this bit here if we're solving? It's divided on this side, so it's times on the other side. What happens now is we multiply out the brackets. 3x equals 2 times that, 1.15, oh, I can't do that in my head, times 2 equals 4x minus 2.32111. All right. Now what do you think you do? Yucky numbers, but...
Minus the 1 point, yeah, 1 to the other side.
Yep, so it's a positive over here, it becomes a negative over here. This stays at a negative. We're going to do that. 3 minus 1.5474. 1.4226x equals that. Last step. Divide this by this. X equals, and just put it in brackets out the back here. Say I'm doing this. I'm going to write it all down. Negative 2.32112 divided by 1.4226 equals negative 1.6323 to 40p. So yes, there's quite a lot to do in it, but all of it is just those same steps that we've been teaching you since year 9, except that one step there. Right? When you're dividing, you multiply on the other side. when you want to get rid of something and it's over here and it's by itself, we subtract it from both sides. So subtract it from the other side, etc., etc. So yep, lots and lots of steps. Okay, one more. This one, they kind of started it for you. I liked this one. I definitely think this would be an excellence question. So if you did only this one, you get 7 marks. That's almost a pass. Right. So, what do we think we might do? Good. First thing we do is we say, okay, that's that plus that, and we know that log A plus log B is log AB. Right, that was our first log rule. So this equals log of x plus 2 times x minus 1. And it equals 1. And another rule that told us what 1 is as a log. What was that? Log A1 equals 1. Okay. Log AA equals 1. Right? Log, we wrote log, little a, big A equals 1. So we need a log here to be able to cancel them out. We're going to use that here. What's the base here? So A is 10. So we've got log 10 here. Right? Because unbeknownst to us, this is a 10. Right? These are all base 10s. So therefore, in this formula, A is 10. So we've got log 10 instead of log 1. And over here, we've got this loggy thingy going on. Again, I think this is an excellence. Scrap the logs, undo the logs, rub them out. Gone. Multiply out. What do we do with quadratics? We solve them by making them equal 0. We actually haven't done that lesson, but I would have thought you'd know from last year. So we have to take away this 10. So we're going to get negative 12 equals 0. Brackets. Multiplies to negative 12. Adds to positive 1. Plus 4. Minus 3. Answers. Negative 4 and 3. If we put negative 4 and or 3 in there for x, we will end up with 1. Try it out. Log of, let's do 3 because I can add 3. Log of 5 plus log of 2 equals? Yes, it worked. We can always be happy with things that work, because if we can go back and check them. So if we put negative 4 in, we get log of negative 2 plus log of negative 3 equals negative 5, sorry, yep. Log of negative 2, log of negative 5 equals 1. I hope. You might need brackets and things. Okay.